This is Algebra 2 with Trig. We're looking at 13.3, Day 2. So we're going to look at a circle with a radius, with a specific coordinate. We have theta, which is the angle. Theta is going to equal our opposite over the hypotenuse. So our hypotenuse in all of these cases is going to be the r value, the radius of the circle. Cosine is the adjacent over hypotenuse, or x over y. Tangent is the opposite over adjacent, or y over x. Now cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. This should be x over r, so this should be r over x, and then x over y. Here we're going to evaluate all 6 trigonometric functions at theta equals 180. So if we visualize the unit circle and the coordinate at pi, which would be -1, 0, pi or 180, whatever you want to call it. So there's our coordinate. We know that the sine of 180 is the y coordinate, so it's 0. The cosine of 180 equals the x value, which is -1. The tangent of 180 is the y divided by the x, which is 0. Cosecant of 180 is going to be the reciprocal of what we have here. Currently we have 0 over 1. So that's going to become 1 over 0, which we know is undefined. You can't have 0 in the denominator. Secant is the reciprocal of -1. -1 over 1 makes 1 over -1, which is still -1. And then cotangent, the reciprocal would be -1 over 0, which is undefined. Those are your 6 trigonometric functions. Now here's a different 6 trigonometric functions. Here we have our coordinate of -8, 15. We know that this is larger than the unit circle because we're 8 to the left and we're 15 up. So making a right triangle with the x-axis, we could look at a right triangle with the adjacent side, because our theta is going to be here. It's going to be the angle that it makes with the x-axis. -8, 15. That puts us up here in this quadrant as -8, 15. And we need to figure out what the hypotenuse is. So your hypotenuse is r, so r squared equals -8 squared plus 15 squared. So that's going to give us 289, and when we take the square root of 289, we get a value of 17. So we know that the radius in this case, or the hypotenuse of the triangle, is 17. So sine of our theta, we don't know what the angle is, so we'll just call it theta. Opposite over hypotenuse is 15 over 17. Cosine of our theta is adjacent over hypotenuse. Tangent would be 15 over -8. Cosecant is the reciprocal, so it's 17 over 15. Secant is the reciprocal, so it's 17 over negative 8. And cotangent is the reciprocal of tangent, which would be negative 8 over 15. When we look at the xy axis and considering our values of sine and cosine, we know that all the coordinates in quadrant 1 are positive. All the coordinates in quadrant 2 that are positive are going to be where the s value, the sine value, will always be positive because that's your y value and that's up. The x values are positive down and the y value. The y values are positive down and the x values are, let me say that again, I'm sorry. The x values are negative to the left and negative down, which makes negative over a negative when you're talking about tangent. So tangent is positive in the third quadrant. To the right is the only values that are positive in the fourth. So we often call this all students take calculus. That helps you remember which trig function is a positive value in which quadrant. All of them are positive in the first quadrant. Sine and its reciprocal are positive in the second. Tangent and its reciprocal are positive in the third. And cosine and its reciprocal are positive in the fourth. So we need to evaluate. If we're going to evaluate where the cosine of negative 225 is, you either need to visualize it or you need to draw it out. I'm going to draw it out so you can see what the visualizing could look like. This says the cosine of negative 225. Well, we know that negative means we're going to go down and around. Halfway gives us to 180. Another 45 gets us right down the center of that second quadrant. That's negative 225. Another way to have gotten there is of taking our negative 225 and found the coterminal to figure out, that's 360, which would be 135. So the cosine of negative 225 is the same thing as the cosine of 135, however you want to talk about it. But the coordinate here, this is a reference angle of 45, so we know that this is going to be root 2 over 2, comma root 2 over 2, and the x value has to be negative. So your cosine refers to the x value, so negative root 2 over 2. This is cotangent. Let's figure out what the coordinate is first. 10 pi over 3. That's 1 pi over 3, 2 pi over 3, 3 pi over 3, 4, 5, 6, 7, 8, 9, 10. So 10 pi over 3 would come all the way around. That gives us a short side and a long side. So we know that this coordinate is negative a half, negative root 3 over 2. The cotangent. Well, I know that the tangent of 10 pi over 3 is going to be y over x. Negative root 3 over 2, comma, negative 1/2. To calculate that, we're going to say negative root 3 over 2 times negative 2 over 1. Those are going to cross out and make a positive root 3. Remember, tangent is always positive in that third quadrant. So that helps justify that that was truly a positive value. Not to mention 2 negatives make a positive. Now, if that is your tangent, our cotangent is going to be the reciprocal of that. Then we need to rationalize the denominator. And we get root 3 over 3. Another way, another angle you could have called this is to have subtracted 2 pi from that. So if we would have taken 10 pi over 3 and subtracted 2 pi, which is 10 pi over 3, and subtracted 6 pi over 3, it's a value of 2 pi, that would have given us 4 pi over 3. That's the coterminal here. So cotangent of 4 pi over 3 is the same thing as the cotangent of 10 pi over 3. Secant of 300. Would be 60 degrees away from the x-axis. So that's helping us realize that we would be short and long. That helps us realize this coordinate is going to be a half and negative root 3 over 2. Well, secant is the reciprocal of cosine. So if cosine of 300 is 1/2, then secant of 300 is the reciprocal of that, which is 2, or 2 over 1. Sine (17 pi over 6), 1 over 6, 2 over 6, 3 over 6, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So we went around once, we went around almost another half time. Another way you could have figured that one out, notice we went around more than once. That's more than 12 over 6. So we're going to subtract 2 pi. When you do that, you get 17 pi over 6 minus 12 pi over 6. That's a value of 2 pi. So that tells you that it's 5 pi over 6. That would be the coterminal. That's the same angle result as 17 pi over 6. It would have the same reference angle, it's called. Anyway, this coordinate is over a long way and up a short way. So we're over a long way, which is negative root 3 over 2, and up a short, which tells you it's a half. So now, if sine of our value, we know that that's going to be a half. Tangent of negative 240. There's our negative 180, negative 240. So we're over a short way and up a long way. So that tells us it's negative a half. root 3 over 2. The tangent is going to be root 3 over 2, which is the y value, divided by the x value, sine over cosine. Multiply by the reciprocal, and we get negative root 3. Remember, that's in the second quadrant, so tangent is going to be negative. That makes sense. Last one. Negative 15 pi over 4. Well, negative means you're going to go down. 1 over 4, 2 over 4, 3/4, 4/4 of the pi, 5/4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I know I'm going in that direction. Because these are fourths, I know that my reference angle here is pi over 4. So this is root 2 over 2, comma root 2 over 2. So cosecant is the same thing as sine. You could say pi over 4. And then we would have to add another 7 pi over 4. Well, take our 7 pi over 4, add another 2 pi to that. So negative 7 pi plus 8 pi leaves you with 1 pi over 4. So we know that that's a coordinate of 1 pi. I've been writing them the same way as what's here, but that would be accurate too. That's called the coterminal. So the sine of this is going to be root 2 over 2. So the cosecant, it starts with a C, so it pairs up with the S. Cosecant of negative 15 pi over 4 is going to be the reciprocal of that. And then you have to rationalize the denominator. You get a root 2 on top. Root 2 times root 2 makes a 2 on bottom, and it crosses out. So you're left with just root 2. On the back side, we're looking at a equation. Distance equals the velocity squared divided by 32 times sine of 2 theta. Theta is in degrees. So if you kick a soccer ball at an initial speed of 46 feet per second at an angle of 30, we're going to take our equation, plug in the 46 for the velocity, so 46 squared over 32 times the sine of 2 times our angle, which is 30. This is going to give us the distance that the ball flies, assuming that there's no air resistance actually for this problem. 46 squared is going to come up to be 2,116 divided by 32. Sine of 60. Well, thinking about the unit circle, we know what sine of 60 is. .60 degrees is short long, So it's 1/2 square root 3 over 2. So we know that the distance is going to equal 2,116 over 32 times root 3 over 2. And we can simplify that and call that 529 root 3 over 16. That's your exact answer. The approximated answer is 57.3 feet. We're going to estimate the horizontal distance traveled by a track and field long jumper. We have our formula. We have a speed of 27 squared over 32 times a sine of 2 times theta. Our 27 squared is 729. Two times 20 is 40. Now the sine of 40 is not part of the unit circle, so we would need to use a calculator for the sine of 40. Just be sure you're in degree mode. We'd want to write down all 4 numbers. There's actually more than 4, but you would want to write down 4 numbers, not round that to 0.6 or round that to 0.64. You'll get a little bit different answer. It won't be as accurate. So in a perfect world, you would use the ANS button, the answer button in the parentheses, or at least those 4 digits. And we'd come up with 14.64 feet. Last one. I've been on the Navy Pier Ferris wheel in Chicago. It apparently has a diameter of 140. So the diameter is 140, the radius would be considered 70. It's 10 feet off the ground. And you board on the gondola and rotate 158 degrees, which would be approximately that direction. Then you're going to stop. What we want to find out is how far off the ground are we when we stopped. So we're going to look at this right triangle. So if we had 158 degrees to get there, part of that was, of course, this 90. How much extra were we? Take your 158, subtract the 90 from it, and come up with 68 degrees. That's our 68 degrees. We know that the radius is 70. The question is, what is the height? How high are we? So we're going to calculate that by saying the sine, which is opposite over hypotenuse, the sine of 68 equals the opposite over the hypotenuse. Put that over 1, cross multiply. 70 times the sine of 68 equals h. Using your calculator, you see that 70 times sine of 68 is 64.90, and those would be in feet. So that's how high we are off this horizontal bar. That's how high this triangle would be considered. But now, let's calculate how far we are off the ground. So, we're 64 feet off the center of the circle. From the center of the circle, how far down do we have to go to get as down as low as possible? That's your radius. So we're going to take the 64.9, we're going to add 70 to that. Then we're going to add 10 more to get all the way to the ground. And those would be in the units of feet, 144.9 feet.